Cool. So we are going to discuss first like how rollups work. But before that, let's dive in deep into what, um, why you would even use a rollup, right? Um, a rollup is just a blockchain that inherits security of another blockchain. So let's discuss why a rollup first. So let's say you want to write your Web3 app. What options do you have? I think the most common way people go about is you deploy your app on Ethereum. So you can do that, um, but for the advantage of that is you get really high security. Um, but a downside of that is it's very costly for users since every user, every app is deploying on top of it can be costly. So another way you can go about it is you can deploy your own chain, an app chain. Um, and with that, sure, the only users on the chain are people using your app, so it's very cheaper, or it's really cheap for those users. But the downside is that you have to maintain your own security of the app, and you have to, and that is very costly, both in money and time. Another way you can go about is you could just deploy on another layer one, which is cheaper, right? But um, but security-wise, again, you might have weaker security. Um, but again, you run into the same problem where now everyone deploys on this, and you run into the same problem that it just becomes costly for users. Another option you have now is you could deploy a rollup. With a rollup, um, you get your own chain, but that inherits the security of another chain. So you get both high security and it's cheaper for users. And if you wanted to retain control and decision-making power, you could deploy something called a sovereign rollup, which is what Rollkit enables for you. And that's something we'll discuss in the next slide and how that works. Any questions about this?
So this is a good example of security versus costs. How does scale impact the decision across these options? In this example, it's kind of clear when deploying an application, the choice between choosing high security and users, and cost to users. I think there's kind of an assumption that ease of deployment is similar across all of them. Curious if it's worthwhile talking about how each of these options scale and how that impacts them, right? And so I guess leading that question, like thinking about deploying on Ethereum as that ecosystem scales, the cost just continues to go up, and whereas like an app chain or something, as that scales, the security does actually go up, so it gets closer. But then at some point, I would assume the cost also then starts going up. So kind of like the how scaling each of these individual kind of like ecosystems or options kind of impacts, and like which one has like the best kind of like long-term scaling trade-offs or benefits.
Yeah, that's a good question. Yeah, so on Ethereum, as the number of users increases, the cost would keep increasing, right? Gas costs increasing. On an app chain as well, but in this case, you're not having multiple apps compete. So in this case, if another app, like another app chain has high activity, your app chain would not necessarily scale, but it wouldn't necessarily have a high cost for users, right? So that is like local to your app. So it's only your users that are competing to execute transactions on the app. And for an alt L1, you kind of run into the same issue as something like Ethereum. And for a rollup, you can also have like multiple rollups on top of that are inheriting the security of a base layer. So as the number of users increase on a rollup, you could have also like multiple versions of your rollups that are that users are using. So that's kind of like scales in terms of costs. For security, you don't to launch a rollup, you don't have to spend more to you just inherit the base security or the security of the base layer. But and in terms of costs for users, those can be also spread across different rollups. So does that answer your question? Yeah. Cool. So move on. So we'll just discuss how a sovereign rollup works and what are the different components of it. So a sovereign rollup is also a blockchain, but it's just it would have just like any blockchain, it would have blocks that are being produced. So but how do these blocks get produced? So when you launch a rollup, you launch something called a rollup block producer, or what is called a rollup sequencer. And when there are transactions that users submit, so users of this rollup are running a rollup light node. So let's say a user wants to submit a transaction. So they would submit a transaction to this sort of like a pool of transactions. Let's say it's just 2 transactions for now. And every rollup, what we call a rollup block time, let's say it's like a second or 2, the rollup block producer will look at this pool of transactions that exists, and this pool is shared across all the rollup nodes. So these rollup light nodes can actually submit transactions to any other rollup node, and this happen to be in this pool. So let's just say the rollup block producer has access to this pool. So all the rollup block producer is going to do every rollup block time is take transactions from this pool and order them. It is also going to produce something called a header from these transactions, and the header has something called a state root, which represents what was the state of the rollup after these transactions were executed. So let's say my previous state looks like is an account A that has 5 units of currency, and this is account B that has 10 units of currency. And a transaction just says that A is going to send 2 units to B. So that's just what the state will look like here. Should be clear. And the rollup block producer is going to create this header from this new state by taking a hash, something we call the hash of this, and it is going to create a header. Now, by combining the header and the set of transactions in a block, is you get something that's what you call a full block. So this is just the block data, and this is the header. So the rollup block producer is signing over the header that was produced. This is just a block. And this block is going to be appended to this chain, the rollup chain. So it has an internal notion of what the state of the chain is. So let's say it's like rollup block height 1, 2, 3, just produced rollup block height 3. So it's a rollup block 3. And it is going to append this and is also going to publish this block to the base layer, which is something which is a DA layer like Celestia. So that is also a blockchain. And that chain usually has bigger blocks than the rollup chain. And how is this block going to be submitted to the DA layer. These rollup blocks, every rollup node runs a DA light node, which is what it's used to submit to the DA layer. So the same block is going to now live on the DA layer as well. So just redraw it. And anyone who would like to run the other type of node is a rollup full node. So that's something anyone can run. That's permissionless. So if anyone wants to verify the state of the chain, or they they would be gossiping transactions to this pool, they will run something called a rollup full node as well. And these nodes have their own P2P layer, but the primary way is they're looking at the DA layer. So the rollup full node is just going to be looking at these blocks. This is just a block. So the rollup full node is also running a DA light node of its own. And the rollup full node is going to do two things. It's going to verify if the state is correct. And if the state is not correct, it is going to notify the network that something wrong happened, and it would halt. So all the full nodes of the network and light nodes will know that there was an invalid state transition if the state is incorrect. If the rollup block producer tried to produce an invalid transaction, the rollup full nodes would halt, and light nodes would also know. So that is how sovereign rollup works. And next we can talk about, and maybe one thing we can go over is, like, that's a common question, is where is settlement happening in the rollup? So sovereign rollups have their own notion of settlement, which means they maintain the state like in rollup block producers and full nodes. So that does not have to be on any other layer. Any questions?
Curious what happens if there is an invalid state transition on the rollup and the chain halts. Like, what is the process after that to recover and restart the chain, or for the chain to continue producing blocks?
Yeah, if a block producer, if there's an invalid state transition, then the rollup block producer is malicious, right? They included an invalid state transition. So in that case, the chain halts, and there'll be social consensus, and the associated, if there's a stake associated with a block producer, that will get slashed, and there you would just start the chain again from the last state that was correct, and there will be another block producer that does that.
And is the stake that you're talking about stake on the rollup or stake on the base layer?
That's sort of like an implementation detail. Yeah, that can be configured both ways. Yeah. Then we're just going to move to how you actually create this rollup using Rollkit. So we'll before this we go over this, we'll assume that you are a Cosmos SDK developer. Right now, the primary way how Rollkit works is through the framework Cosmos SDK, which is a framework to build blockchains. So if you're a Cosmos SDK developer and you have written your app logic already, and now you want to launch your chain, how would you do that right now? is you would have to, before you launch a chain, you would have to gather a validator set, um, and that, and you would have to like bootstrap your own security for that validator set. So, and that is like a huge effort. It costs a lot of time and money, and so that's how you like launch a Cosmos SDK chain right now. But now using Rollkit, all you have to do is you can plug Rollkit in your app, and you can decide an already existing block DA layer like Celestia, and you can inherit the base, inherit the security of that base layer, and you can launch your chain. Just using the same app, you can just plug Rollkit in your app, and you would just launch a rollup block producer. And the benefits you get is nothing, all the existing tooling around the whole Cosmos ecosystem, you get that out of the box. So what is that tooling? You still get ABCI++, still IBC compatible, all your wallets that you're used to, you still get support with them. And you have full RPC compatibility between all your tooling with block explorers and such. And last thing is you would also you would retain full sovereignty over your app, so you don't have to give that up to another chain. What does that mean? Like, if there is like ever a bug in your app, or your app like has a exploit, then you don't have to worry about not being able to fork because you settled on a different layer. You can fork easily, and you can just upgrade to the fixed version that the community decides, and you can still have all the great, like, you can still have on-chain governance to do those upgrades. So that's what you can do with Rollkit. And if you want to learn more, you can go to our website. It's rollkit.dev. Look through it, launch a rollup, and if there's any feedback, just talk to us and reach out via Telegram. Yep. Yeah. Yep. Are there any questions?
Yeah, I had a question about like the before and after picture, and the differences between having a validator set and maybe like a single sequencer or a few sequencers.
Yes.
Can you explain more about like what the security assumptions are, I guess, or like what you inherit as far as security goes between like a Cosmos chain with 1,000 validators and like a single sequencer?
Yeah, that's a great question. Yeah, so that's if you have a Cosmos chain with 1,000 validators, right? Every block like all those validators are re-executing those transactions and coming to consensus, right? And they have their own security that they have to bootstrap. But in the case of a single sequencer, you're not actually you're only trusting the sequencer for liveness. So, which means if the sequencer goes down, then the chain will halt. But if there is an invalid state transition, then you, depending on the rollup type, if it's a pessimistic rollup, then there's rollup full nodes that can detect that. And if it's an optimistic rollup, there's fraud proofs being generated by these full nodes to all the network participants. And in the case of ZK rollups, each block that gets produced by a sequencer has to be accompanied by a ZK proof, right? So with a sequencer, that is just inheriting the security of an existing chain, the DA layer, like Celestia. So that layer already has also a validator set, right? So the sequencer is actually getting security from that layer's validator set. So you don't have to have your own and do all this work too, which costs a lot of time and money. So that's a common misconception that you're going from a huge validator set to a smaller one. But in this case, you're still inheriting the security of the DA layer. Any other questions? Cool.